Morning geometry. It's Monday, last Monday before Christmas break. We are starting TT4 today. It's a pretty short section, so we shouldn't have any problem getting it done this week. And we're starting with the triangle inequality theorem. So I want you to open up this document, and I want you to click on the GeoGebra link and open up this page. If you zoom out to about 90%, you'll see the whole page, and it'll be easier for you to scroll up and down. Okay. So the triangle inequality theorem. Does any three values make a triangle? If I give you three random numbers like 10, 9, and 25, can you make a triangle with those side lengths? Well, that's the question. So if we're looking at this document, we have makes a triangle column on the left and doesn't make a triangle column on the right. So they started with 3, 4, and 5. So let's check that out in GeoGebra. So you need to set the three sliders to 3, 4, and 5. Doesn't matter which order. And then move the yellow dots and see if you can connect them to make a triangle. And when you do, you get this little message. Okay. So yay, you made a triangle. So 3, 4, 5 does work. So let's go back to the Cami doc. So 3 here is the shortest side. 4 is the medium side, and 5 was the longest side. Now this 7 is the 3 and 4 added together. And this greater than sign is 7 is greater than 5. So that's why that's a greater than sign. All right, let's check out what they did with 2, 2, and 8. So I'm actually going to make my A the 8. Okay, so then I want to connect my yellow dots. And no matter how I stretch them, they're just not going to meet. Okay, so 2 plus 2 is 4. 4 is less than 8. So that's why we have our less than sign right there. Okay, so now we're going to try some more. If you have a dice, go ahead and grab it. Otherwise, you can just open up a web page. You're going to do a 6-sided dice. You actually need 3 of them. No. Okay, I don't know what I did. Okay, so I rolled a 5, and a 2. So if I go back to GeoGebra and I set a 5, and a 2, can I make a triangle? Woohoo! It made a triangle. So I'm going to go back over to Cami, and it made a triangle, so I'm going to use the left-hand column. 2 was the shortest side, and then I had a 5, and then I had a 5. 2 plus 5 is 7. 7 is greater than 5. Okay, let's do another one. I have a certain one that I'm thinking that I'd like you to see. Okay, let's take a look at this combination with 2, 3, and 5. Let's go back into GeoGebra. 1 to 2, 1, 3, and 1, 5. Now, if you try to connect these, you get pretty close. They don't actually connect until it looks like a straight line. So is this a triangle? The answer is no, it's just a straight line. And this might remind you of that part plus part equals whole segment addition thing that we did forever ago. So when you're filling in your Kami document, we had a 2, a 3, and a 5. And what symbol is going to go in our bubble? Well, it's an equal sign because 5 equals 5. Okay, so I want you to continue rolling the dice until you actually fill in this whole document. If you run out of triangles on the left, then just keep rolling until you get more that are not triangles. And then I want you to look for the patterns in the bubbles. What's going on with these symbols? Once you finish that first page, you can do this second page without actually using the GeoGebra app, because you should have a generalization statement from question 2 that you can use. Same thing here. For this section, you're going to use Desmos. So let me pull that up. Okay, here's the link for Desmos, and it's in your assignment. And we're just going to add these points in. So the screen starts out looking like this. The first point was -2, 4. You've got to have that opening parentheses. And then it's 6, -6, 3. 6, 3. And lastly, it was -1, -5. Now, it plots the 3 points, and it's your job just to look at them and say, is this a triangle or is it not a triangle? Well, you could connect those 3 dots and it makes a triangle. So on your Kami document, you're going to write, yes, simple as that. So plug in the 3 different points to Desmos and then decide whether it's a triangle or not. All right, for this last section, you need to determine the range of possible lengths for the third side. All right, so based on your triangle inequality theorem, you know that the 2 short sides must be greater than the longest side. So if we did 12 plus 18, that is 30. So 30 wouldn't make a triangle. That would be one of those flat lines. So 30 is actually just larger than the largest side. It could be 29.9 and it would connect. It would have a tiny little bump where the triangle is. To find the smallest side, we're actually going to do 18 minus 12, and that equals 6. So we would have a 6, a 12, and an 18, but 6 is too small and makes it flat. So we need something that's just bigger than 6. So that is our range. Just bigger than 6 up to just smaller than 30, because 6 and 30 are where they flatten out. Let's do one more with you. So if we had 6 and 10 to make the big one, we're going to do 6 plus 10. To make the smaller one, we're going to do 10 minus 6. So the biggest it could possibly be is 16. So it's actually just under 16. And the smallest it could be is 4, just greater than 4. All right. And that is what you're working on today. I'll see you the last 10 minutes of class for the Google Meet.